Okay, this section is about simplifying roots and radicals. So a radical is anything that has this symbol right here. So usually we've been doing a lot with square roots, but you can also have cube roots as well, and fourth roots and fifth roots. So to simplify this, there's two ways that you can do it. You can factor out this and write 7 times 7, x, and 10 y's. That's kind of the long way, but people like to do it that way because it makes sense to them. And then you can pull out groups of 2, so 7 and x, 2, 3, 4, 5, y to the 5th. And there's nothing in the inside. That's one way you can do it. Or what you can do is take the highest perfect square that goes into 49, which is 7. And then if this is the square root, you can divide 2 by 2 and get 1, and 10 by 2 and get 5. You can do it that way. Number 22, or the next problem. If you're multiplying square roots, instead of, what I would do is I would factor out each one, 2 times 5, and write them underneath the square root together. So 5 times 2 times 2 times 2, this is the square root of 40. Put them under one square root. You can multiply roots that have different numbers underneath, but you can't add numbers. You can't add roots that have different numbers underneath. So I'm going to pull out doubles. So I have a 2, another set of 2, and a 5. So the answer is 2 times 2 times 5, which is 20. Same thing with this one. I'm just going to factor out, so I have a 7, x, and then 14 is 7 times 2 times x. And now I have 2 7s, so I can take one of them out, and I have 2 sets of x's, so it's going to be x squared. So the only thing that's left inside is a 2. And then 29, this cube root, you don't want to leave a root in the denominator, you would rationalize it, but first I'm going to reduce it. So I could write it together as 1 cube root, so 56y to the 5th over 7y. And the reason I'm doing that is because I can actually reduce this. I can actually divide 56 by 7 and get 8. And I can divide y to the 5th by y to the 1 and get y to the 4th. Now I'm doing the cube root of 8y to the 4th. So this is going to be 2 times 2 times 2, and then 4 y's. So when you're doing the cube root, you take them out in groups of 3. So I have 1, 2, 1y, and 1y left on the inside that doesn't have another group of 3. So make sure that you're writing the cube root right here. So that's my answer. And then the next problem, again, they both have square roots, so I'm going to write them together and then reduce it. So it's 216 x cubed y squared over 2. So I can divide 216 by 2, so it's the square root of 108 x cubed y squared. So now I can break down the square root of 108 is 54 and 2, 27 and 2, 9 and 3, 3 and 3. So you can write them all underneath the square root. So it's 3 3's, 2 2's, 3 x's, 2 y's. So it's a square root, so I'm going to take them out in groups of 2. So I have 1 3 times 1 2 times 1x times 1y. So this reduces to 6xy square root of 3x and then number 39, oh, I think I skipped one over here. Okay, so you can't just go ahead and add these together because they're not like terms. They need to have the same root underneath. So if I break down the square root of 27, it's 3 root 3. You could go ahead and break down the square root of 75 is 5 root 3. You can break down the square root of 12 is 2 root 3. So I have these all broken down. Now they all are root 3, so now they're like terms. So I'm going to combine their coefficients. So I do 3 plus 5 minus 2, so it's 6 root 3's is the answer. Because 3 plus 5 is 8, 8 minus 2 is 6. And then down here, graphing each square root function. So a general square root function looks like this. It looks like half of a parabola starting at 0, 0. So this is the function, the y equals the square root of x. Because if you think about a table, your domain, the possible x values, you're not going to plug in negatives for x to take square roots of negative numbers. So if you let x be 0, 1, 4, 9, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So if I go over 0, 0, 1, 1, 4, 2, we'll go over here. And then it just keeps going 9, 3. So it's gonna kind of like flatten out like this. It's gonna be half of a parabola sideways. So what this function is doing, it's taking your general square root of x and it's shifting it up 3. So you're just gonna basically add 3 to all these y terms. So what it looks like on a graph is you're going to start, and you can make a table too to be more precise, but you're going to start at 3 and do the same thing. We're just going to the right. Number 76 is now it's underneath the square root where you're subtracting 1. So what this is going to do is it's going to shift it to the right one. Kind of like the vertex form of a parabola, it's going to go right if it's negative and left if it's positive. So it starts at 1, 0 and goes this way. And you can make a table too to look at that.